Thank you so much for having me. My name is Mike. As you can tell, I'm a long way from home. I am from Salt Lake City, Utah. I have an amazing job in that I get to travel the world and argue with people about the right way to manage infrastructure, which is fun, but also you all are an opinionated bunch, so it's also sometimes very exhausting. And I've really enjoyed this conference today. It's truly been one of the better conferences, and I go to a lot, and this has truly been one of the better conferences where I think people are saying some really, really smart things about how to manage infrastructure, and it's really reminded me how jealous I am of your job, because there are so many amazing tools out there, and I hope that if nothing else, by the end of today, you will have taken the time to check out some of the products by Mitchell and his group over at HashiCorp and others, because I'm really jealous that all of you get to use this stuff in the world. But anyway, like I said, I'm Mike Place, and I'm the maintainer of SaltStack. And what is Salt anyhow? Well, Salt is an event-driven continuous automation engine. And what that really means is that Salt grew up in the shadow of bigger and much more famous projects like Chef and Puppet, and of course CF Engine, the project by Mark Burgess that showed us all the way in the 1990s. And Salt really operates on a principle that I think is a little bit different than everybody else. And one of the things that's really important to us and is really important to me is that automation acts as a first-class citizen in the infrastructure, because so often, especially when you look at the history of things like configuration management, we think about configuration management and automation as something that primarily operates in the first few moments of an instance's life, right? That it deploys an image into the cloud, or it takes a base image and applies some set of configuration to it, and then more or less makes sure that it doesn't waver. Well, that stuff is all important, and it will never not be important in my view. But I also tend to believe that automation can do a lot more, that it can exist and be pervasive up and down the stack, and that it can operate not just at the birth of an instance, but it can operate moment to moment as a part of the application, as a part of the infrastructure, for self-healing, for auto-remediation, as a part of CI/CD, as a part of security remediation, or what have you. So the Salt open source project, just to give you a brief idea, is an extremely busy project. It's one of the busiest Python-based open source projects in the world. We tend to see somewhere between 10 and 20 pull requests a day. It's not unusual for us to merge between 1,000 and 5,000 lines of code a day. We have about 2,000 active contributors. This stat's a little bit old. I think we're just coming up over 90,000 commits. Salt is the technology behind stuff like SUSE Manager, for example. It started out in the early days of Kubernetes as being under the hood at Kubernetes. It's not anymore, but runs some of the largest infrastructure in the world. That's places like LinkedIn and IBM Cloud, other places like that. So let's dive into the way that Salt operates right out of the box. So what Salt does is it has what we call a master minion topology, which is just a fancy sort of branded way of saying it's a client-server topology. So we have machines which are called masters. Masters are the controlling machines, and the machines which are under control, the managed machines, are known in Salt nomenclature as minions. If you've ever seen the movie Despicable Me, this will start to sound very familiar to you. Masters and minions, by default, maintain a persistent connection to each other. That connection takes place over 2 TCP ports by default. They come inbound to the master from the minion, and they stay up for the lifetime of the minion process. And so typically that can be many days or many weeks or what have you, really until the minion process itself restarts for some reason. But the connection between the master and the minions has a logical entity that we call the Salt event bus. The Salt event bus is built on top of a transport using the open source messaging project called ZeroMQ, right? It's a high-speed message queue. It's designed for large infrastructures that need to push many thousands or tens of thousands of messages a second across a bus. And so in this topology, this is effectively pub/sub. And so the master publishes messages to the minion that may, ask the minion to do some work, to apply some configuration, to perform some other actions. It does this all at once, right? So this publication can be instantaneous to all connected minions. And when I say all connected minions, this scales quite a bit. It's very common for us to see minions connected to the master, 10,000, 20,000, 50,000 machines connected to a single master. So this gives us the capability to address a large number of machines and to send commands to these machines effectively simultaneously, have them do some work, and then report the results of that work back to the master across the event bus. So Salt gets lumped in with, like I said, Chef and Puppet and Ansible a lot of the time. But one of the stories that I like to tell is that configuration management is not the problem that we originally set out to solve. So if you'll indulge me with a quick story. When we started Salt, the problem that we wanted to set out to solve was essentially remote execution. Right, we wanted to be able to say, okay, we've got 10,000 machines, and we want to be able to run command such and such on all of these machines at once. And we did this, and so we built out Salt to do this, and that worked really well. And about a year later, the community that started to form around Salt came back and said, we could put configuration management on top of this. And we said, okay, well, we'll do that. And it was about that time that LinkedIn called us out of the blue and said, yeah, we're using Salt in production. And we said, oh, wow, really? Cool. That was a great surprise to us. But the point of this story is that we see, again, automation as a first-class citizen, but configuration management as a service that exists inside the automation ecosystem. Configuration management is what does the heavy lifting, what gets these parts to move, but automation is a much more robust problem than simply configuration management. So when you look at Salt, there are four main areas that we try to address, right? The first is remote execution, right? Which is basically, okay, send a command out to a bunch of minions, have them do this work, and have them send the results back. That's really simple. Now, one of the debates that you hear in this space a lot of the time is the debate between agent-based and agentless approaches, right? So, to name names, right, our friends at Ansible like to talk about an agentless approach, right, where an agent doesn't sit out on the remote end. It just has an SSH daemon, which I would point out to them is, in fact, an agent. But never mind that. And so in an agentless approach, what happens is your configuration management system goes out, connects to SSH, deploys a little bit of code, does the requested work, and then tears its connection down, and you don't have a persistent connection there. In an agent-based approach, obviously, you have a daemon on the remote end. That daemon is consistently listening, consistently connected upstream, and is quite a bit more performant. Now, Salt supports both approaches. It is both agent-based and agentless. If you want to use the approach where you don't need an agent on the remote machine and you just want to use SSH, cool. If you want an agent-based approach, also cool. So for those of us who are Python programmers, Salt tries to take an extremely Pythonic approach to the way we handle things. And I'll show you this in a minute when I get into demo, because I have a weird form of dyslexia where I can't remember anything that was presented in PowerPoint. But with Salt, you can address the remote execution commands that you want just by giving a module name and a function name. And I'll show you how this corresponds to the way that we've laid out the software in just a moment. So the second area, of course, is configuration management. We should all be fairly familiar with what configuration management is. Configuration management essentially is this idea that we can send idempotent commands to a machine and say, for example, okay, machine X, make sure that package Y is installed, right? And so when your configuration management engine goes out there, it looks at the machine, it checks to make sure, checks to see if the package is installed. If it is installed, it does nothing. If it's not installed, then it goes and it figures out how to install the package so that we're not just doing the same work again and again and again in a procedural way. So our configuration management system looks very similar to other modern configuration management systems. I'll show you a demo of this in a minute. But by default, the way that we describe the configuration of a system is in YAML. For those of you who aren't too familiar with YAML, I will explain everything you need to know about YAML in 10 seconds, so time me. Okay, ready? If you see a colon, it's a key value pair. If you see a dash, it's a list. Indentation represents membership. Done. Right? That's all you need to know about YAML. If you remember those 3 rules, you'll be set. And so, as you can see in this example, this shows what we call states. We have 2 states here. The very top indicates that there's a state called Apache package. We have a package state. We say the package needs to be installed, and we say that the service needs to be running. One thing that's important to note here down on, I believe that is line 8, is that a gentleman described earlier how Ansible is really easy to use because it effectively just runs in order, right? And you don't have to deal with this complex requisite system. Again, Salt takes both approaches. By default, it's exactly the same way. It's procedural. It does A, B, C, D, exactly how you lay them out, right? So it's very easy out of the box, but it also has a complex requisite grammar, which allows you to create dependencies if you want to, and those dependencies can be as simple as ensuring something is required. So A requires B. It can do things like say, okay, do B if A reports changes, things of that nature. So the third area is the event system, and that's what I'm going to focus on primarily today. On this event bus that I described between the masters and the minions, all of these events continually flow from requests for these minions to perform particular bits of work, to returns, which is information about the work. But the interesting thing with Salt is that you can configure a Salt master such that when it hears about particular events, it knows what actions to take. Right? And we'll look at a demo of that in a minute. So that could be things like, for example, let's say you have a CI/CD system, right? You could emit events onto the Salt event bus about what's happening in your CI/CD system, and you can configure your Salt nodes to react to those events, right? So you could say, oh, okay, that way, okay, bam, a deploy event hits the bus, and everybody sees that message, and they know immediately what to do, which both gives you this common bus on which to transmit these messages, but also a really simple way to reason about this stuff. So instead of connecting all these disparate APIs or creating some sort of complex service mesh, you can just say, okay, look for event X, and then perform action Y. We'll see how that works in a moment. The last piece is cloud management. So Salt has a piece of software that allows you to provision containers, to provision into private clouds, to provision into public clouds, to provision onto bare metal, so on and so forth, right? So those are the 4 main pieces. With that, I kind of, like I said, want to get away from slides and actually look at code, which I think is far more interesting. Let's bigify that. Cool. Okay. So, and if I skip over any of this stuff in a way that is not satisfying to you, please like raise your hand and call out and tell me to slow down or what have you. So let's take a look. So I'm going to do this, because it's 4:15 in the afternoon. We'll make this spicy and do it from the develop branch. So we'll see how how well my developers have been behaving today. So let's do something like, okay. And how about we do this? How about we don't? How about we do this? Okay. So I wanted to first show you the remote execution framework. Salt ships with a large number of remote execution modules, and those do all kinds of things, but the main point about them is that they can abstract away the differences between systems. The nice thing about this is that execution modules, if you know any Python at all, and even if you don't, are exceedingly easy to write and exceedingly easy to use. So let me show you our test module here. All right. It's literally as easy as this. So you see, for example, here's a Python function. It's called echo. It takes an argument called text. It returns text, right? So that should be hopefully totally obvious to everybody in here. That maps into our remote execution framework just like this, all right? So you can see we have test, which is the name of the Python module, echo, which is the name of the function, and then an argument that we pass in, and we are off to the races. So I wanted to show you too that we talked about this agent-based versus agent-less approach to things. Okay. Oops. Let's see. Okay. So if we do something like salt SSH, all right, and then I'll do this with the debug flag. Okay. So what this is saying is, okay, from my local machine, we're going to connect to this remote server, run a remote execution command, and return the results back to us. So there we go. We're off to the races, and there are our results just like that. So the nice thing there is that, obviously we're just doing a demo with one machine. We could do this with 100 machines, what have you. The configuration for that looks like this. All right. Nobody log into this and do terrible things because there's a password sitting there. But it's super straightforward, right? Host names, users, passwords to connect to remote machines. So that's all super straightforward. Now let's look at something a little bit more interesting, which would be the configuration management side of things, okay? I mentioned that our configuration management syntax, what was that? Sorry, I thought somebody said something. Our configuration management syntax is, by default, is YAML. If you don't like YAML, you can use JSON. From Salt's perspective, we're just ingesting data. And in fact, if you want to write your own serializer or you want to use a different serializer, if you like the DSL way of doing things, we have PyDSL. As long as you ship Salt a data structure, we're good. Like, we don't really even care. But like I said, it's YAML by default. So here is how simple that configuration management syntax looks. On the top line, we give it an arbitrary name, and then we give it using the same type of syntax, this dotted notation, the state module that we want to use and the function that we want to use. Here we call this file.managed. So if we go to the states directory, and of course this all has HTML public documentation. I just like to show you the code because I think it's more interesting. Here's this, all right? And it's exactly the same idea. We're accepting arguments and keyword arguments. Of course, all the documentation is here, right? And those arguments and those keyword arguments map directly into this state file. Oops. Like this. So what this is saying here is basically, okay, we want to write out a file to the system. Excuse me. we want to templatize this file using the template that we're here calling secret file. We want to send it to temp.foo, and we want to use a Jinja template. This is really similar to other configuration management systems. So if you look at secret file, Salt also has a secret system where the master can control a set of key value pairs, and it can segment which connected minions have access to which key value pairs. We don't need to get into that, but it's really easy to do. And that system is called the pillar, right? Incidentally, again, to tip our hat to our friends at HashiCorp, if you want to use something like Vault, that can just be dropped in to Salt, and you can use it there just as easily. But anyway, you can see here that we're just templatizing something that comes from the pillar, right? There it is, right? Foo equal bar. And so we templatize that into this file. Right, oops, using Jinja, and then we're off to the races. So again, if we do something, I'm just applying this locally. Okay. Here we're calling state.sls, so we're calling the state execution module, the SLS function, which basically says, okay, Salt, use the state execution module to initiate the configuration management engine using and pass it the state file demo. And there we go, and there's temp foo, and just like that. So one thing that's very important to us is that not only do we believe the transport should be very fast, but we also believe the configuration management engine should be very fast. As you can see here, it did this in 51 milliseconds. You'll notice that if you build out Salt states with a complex series of requisites, Salt does a really, really good job of compiling those requisites down to an ordered tree very, very quickly. I don't have a demo of that, but you can trust me, or we can look at it together later if you like. So anyway, that's something like the configuration management engine. Now what I wanted to show you that I think is a little bit more interesting, if you'll indulge me, I've put up a couple of machines here, and I talked about this event-driven model in which we can emit events across the Salt event bus, and then we can react to those events to do certain things. So I've got two machines here. This first machine, this is called MP Demo, has both a master and a minion on it, and I want to walk through a little example that I put together this morning. And so I was imagining, okay, let's say we have a problem. Do you guys remember fail to ban? Like, do any of you run that in production still? Okay, so imagine your boss comes to you and is like, okay, our problem for today is, and I'm not saying this is a real problem. It's an imaginary problem. I made it up. So don't actually do what I'm about to do in production. Don't do it. Anyway. Say your imaginary boss comes to you and he's like, okay, our imaginary problem for today is that we want to do something like fail to ban, but we want to build this crazy distributed firewall. And the way it's going to work is that anytime somebody attempts to SSH to one of our machines, that for weird reasons are open to the internet, but anyway, imaginary story. Anytime somebody SSHs to one of our machines and gets the login incorrect, what we want to do is we want to add that source IP address to an IP tables rule. But here's the tricky part. We want to add that anytime somebody hits machine A and we detect that, we want to add that firewall rule to our whole fleet of 10,000 machines all at the same time. So you're like, okay, cool, and you start to think about how you might do this. Well, I'm going to show you how we can do something like that, like an event-driven automation approach in Salt in about 15 lines of code. Okay, here we go. So the first thing we're going to do is we're going to look at the master, and we've got a really simple configuration here for the reactor. So Salt ships with a system called the beacon system, and what the beacon system does is it can check a machine for some condition, right, in a fairly tight loop. And if it detects this condition happening, then it will simply emit an event onto the event bus, right, that the master can hear. And if then the reactor system, if it hears that event, it can respond by, well, running a reaction, okay? So what we've done here is we have told the master, okay, if you hear anything on the event bus that matches this tag, right, salt, beacon, demo machine, you can use globs in here, I was being lazy, from the beacon btemp, then react to that by running react.sls, right? Super simple. Okay, so let's look at what's in react.sls. This basically just says, okay, what this is going to do is we're going to react to a fail login by ensuring compliance everywhere, okay? Here, all right, I was being lazy, but this could be something like this, which would basically say, okay, so we know that if the reactor hears this tag on the event bus, we're going to run this reaction. And this reaction is going to be, we're going to apply the state everywhere, all right? I'll change this back to demo machine real quick, just for the purposes of a demo. We're going to run this state. We're going to give it the argument of the state that we want to apply, and we're going to give it some information to templatize, which will be the host name that comes in from the beacon, okay? And so the last piece will be something like this, which is basically just a regular salt state file, and all this says is, okay, apply the IP table state, the function append, and simply go ahead and ingest this as the source. Okay, so now here comes the part where we learn if I will be embarrassed or not. Okay. Okay, so basically we have no IP tables rules here. Let's go ahead and, oops, tail the log. It's so much harder to type when there are like 50 people in front of you. Okay. And let's get the password wrong. And okay. So what happened was that minion had a beacon which was watching varlog btemp, detected that a fail login happened, emitted that event on the event bus back to the master. The master noticed that event, noticed that it had a registered reaction to it. That reaction said, okay, anytime you hear this event, then go ahead and target this set of minions and apply this state with the given data, where the given data is the host name of the attacker, right? So now, right, we have done it. So of course, if we change this to, okay. So now, just to prove that we could do this across multiple machines, here's a second machine connected to that same master. And if we change this so that the target is all machines, we have now done so. And let's run our little attack again. And we have done it on the second machine. So that's a really, really simple, sort of very contrived example of how you can implement an event-driven policy using Salt to build what is, would be considerably more difficult to build in perhaps another way. So in terms of my presentation, that's pretty much all I have. I'm certainly happy to take questions or to talk about parts of the Salt ecosystem that I didn't cover or parts that I did cover which may not have been entirely clear. So anyway, thanks and questions.
Hello.
Hello.
Yeah. Sorry, you probably mentioned that, but it's getting a little late. But
sure.
For this beacon thing to work,
yes.
Do the minions have to run the agent?
Yes, the minions have to run the agent. I didn't show you the beacon config, so let me show it to you now. I will show you first off, because like I said, I really just like to look at code. Oops. So you've got all these beacons that ship with Salt, right? The one that we were using was called btemp, right? And again, this is just pure Python. If you go and read it, like it's shockingly easy to understand. On the minion, okay, it's just configured just like this, right? A set of beacons to run, and then when the minion starts up, it goes, okay, these beacons are configured, and it's running those in a tight loop. All right. Some of those beacons accept parameters. So for example, like there's a load beacon, right, that basically says, oh, fire if load is greater than X, or fire if load is, X, between X and Y, what have you, right? Again, syntax for writing beacons is super, super easy. So you can like map this to whatever, sort of dynamic use case you have. Yeah. So cool. Does that answer your question? Yes. Sure. Any other questions? Yeah, one there. Yes. Sure. Yeah, of course. Right, so they're out of the box. The first thing I should say is that the message bus is encrypted, right? It's a public key exchange to start, and then symmetric AES for the lifetime of the connection. But the master holds the public keys of the minion, and then there's a CLI utility. I'll show you here. All right, so if you run this guy, you can see that we've accepted the keys of these two minions which are connected, which is something that I did by hand prior to this demo. Right, yeah. You can also like pre-seed keys, right? So if you're bringing up machines dynamically, right, and you want to put a public key on that machine at provisioning time, and you also want to hand that to the master, then they can connect immediately the first time without any sort of intervention. So there are a bunch of different strategies for doing that, but yes, certainly there's authentication and authorization during that step. Yeah. Cool. Any other questions? Yeah, please.
Thanks first. Can you tell us some more examples on when to use this beacon system? I'm thinking of when you change a file or something, restart a service or something.
Sure. Yeah. Changing a file is a really common one. Let me show you kind of the list of beacons that we have here. Like anything that would sort of plug naturally into a monitoring system is an obvious choice. We have stuff like wtemp here, service, right, which basically does service monitoring, right, service start, service stop, what have you, and iNotify, right, which does file changes. So we see that one used a lot, right, especially in like security-sensitive situations. So file is changed. At that point, you don't have to wait for your sort of regularly scheduled, super heavy configuration management job to come along, right? It immediately rectifies itself. So we see that used a lot, like I said, in security remediation. So those are the ones, process. We have a PS beacon, right, that watches a process list, right, for rogue processes or for processes that start. But our methodology is, we do some batteries included, but we try to make these things easy enough to write that it should take you, only a few minutes to figure out the knack of how to write your own beacon if you have a specialized use case.
Thanks.
Sure. Yeah. Any final questions? Okay. I'll be around if anybody wants to follow up or talk more about Salt or just about automation in general. So thanks very much.
Thank you, Mike.